All right, guys, welcome to lesson 2.8. This is an explain everything video where your job is to listen and follow along, and hopefully you will be able to understand the concepts in this lesson. So as you can see, it is starting with a bell work. I am going to skip that and let you guys work on that. That's a lot of the stuff that we did last class on ratios and proportions. So instead, we're going to move to the second page. Okay, 2.8 is proportions and similar figures. So you are going to see a lot of overlap from the previous lesson to now. Today we are going to be comparing similar figures. Similar figures are figures that have the same shape but not the same size. So you can see right here with these two sailboats, that would be an example of similar figures. They're both triangles, but they're not the same size. Also down here, these two triangles are similar figures. Okay, in math, whenever you see this little squiggly symbol right here, that symbol means similar to. So we would read this statement right here as the triangle ABC is similar to triangle FGH. In similar figures, the measures of corresponding angles are equal and corresponding side lengths are in proportion, guys. That's what we did the other day. The order of the letters when you name similar figures is important because it tells which parts of the figures are corresponding parts. So because they list triangle ABC is similar to triangle FGH, the following is true. A matches up with F. So I always say first letter goes with first letter. Angle B is congruent to angle G. Middle letter is congruent to middle letter. And then finally, angle C is congruent to angle H. Third letter and third letter. And then similarly, we can follow that order to match up which sides are in the same ratio. All right, we are going to need to set up proportions to help us figure out missing lengths from similar figures. And when we do that, we always need to compare corresponding sides when writing the ratios. And then we always need to be consistent by keeping sides of the same figure either in the denominators or numerators. So one of the things that they did here is they were like, okay, well, triangle ABC is obviously the big triangle, and triangle DEF is the small triangle. So if we did side AC, that matches up with side DF. You see that right here. And that went from big to small. So then you've got to keep that same order over here, big to small. And so then they just did B to C, and that matches up with E and F. Order is very important. So let's go ahead and try to put this all together in a problem. It says in the diagram, triangle ABC is similar to triangle DEF. What is DE? So guys, what I'm going to do right now, since we are really looking for DE, we don't know what that is, in my figure, I'm going to go ahead and mark DE as an X. And now I need to set up a proportion. So I'm going to do it the way that they just showed me on the last page and make my triangles go big to small. And you guys can see, here's the large triangle or the big, and then the small one. So in setting up my proportion, I'm going to go ahead and say 10. That matches up with X on the small triangle. And then I'll go 16, that's the big triangle, matches up with EF or 12 on the small triangle, big to small. From here, once I have my proportion set up, now we're going to do it like we did last class, cross multiply. So X times 16 gives me 16X. That's going to match up with 10 times 12 or 120. And then from here to solve it, we'll just divide each side by 16. And so 120, let me get my calculator, 120 divided by 16, I end up getting X equals 7.5. And that was for this side DE. Always make sure your answer is logical if you take a look at those two triangles, 7.5 is a reasonable answer there, okay? As we move on in this problem class, it's now asking me to find AC. So in taking a look there, I'm going to go back to these figures, and this time I'm going to call AC Y. So if I match Y up on the big triangle, that goes with 18 on the small triangle. And then I'm going to use my 16 on the big triangle and 12 on the small triangle. And once again, class, we're going through and we're just going to cross multiply. So move this up for just a minute. As I cross multiply, I'm going to have 12 times y, or 12y, equals 18 times 16, which is 288. Divide both sides by 12, and we get 24. Y equals 24. Now, once again, if you go back up into that figure and you plug that 24 in there, you just do a quick check. Is it logical? And yeah, that does seem logical. All right, guys, in problem 2, we are going to be applying similarity. It says the sun's rays strike the building and the girl at the same angle, forming two similar triangles. That's basically what this lesson is about, similar figures. How tall is the building? So again, I have a small triangle and I have a big triangle. I'm going to need to set up proportions based on the given measurements that we have. So I'll begin by taking 3 and matching that up with 15. So it's going to be like saying the base of the small triangle matches up with the base of the big triangle. And next I'm going to go to another side of my triangles. This time I'll go to the height. So the height of the girl is 5 feet. The height of the building, which is what we're trying to find, is x feet. So I'm going to go 5 over x. I set mine up each time small to big. From here, we're going to cross multiply, so we get 3x equals 5 times 15, or 75. Solve each one by dividing by 3, so we get x equals 25. If I plug that back into my figure, 25 feet for the height of the building is very reasonable. Okay, now this is technically one in class I would have you guys try, but I will just help you to set this up as well. So we can see we've got a small triangle, we've got a big triangle, and I'm going to do the same thing. Small, over big. Okay. So in taking a look, it says a man who is 6 feet tall is standing next to a flagpole. The shadow of the man is 3.5 feet, and the shadow of the flagpole is 17.5 feet. What is the height of the flagpole? So we're going to set it up where we're going to say 6 over x, and what I'm doing is I'm matching the height of this triangle and the height of this triangle. I know it seems a little weird because it's kind of leaned over, but they do really match up. And then we're going to set that equal to, on the other side, the bottom of the triangles, the bases, 3.5 and 17.5. Notice I always did small over big, and from here, class, we just cross multiply now. So x times 3.5 is 3.5x, and then 6 times 17.5 gets me 105. Divide each side by 3.5, and you end up getting x equals 30. 30 feet for the flagpole, that seems pretty logical. All right, guys, on problem 3, we're taking a look at a scale drawing. The problem reads, what is the actual distance from Jacksonville to Orlando? So you can see on the map, here's Jacksonville all the way down to Orlando. Use the ruler measure to measure the distance from Jacksonville to Orlando on the map. Well, one of the things I start with, guys, and I showed you this the other day, is I start with the scale that they give me. The scale that they give me is 1 inch to 110 miles. Now, I'm trying to figure out the number of miles it is from Jacksonville to Orlando. So I need to really read this ruler to see the distance from Jacksonville to Orlando in inches. And the distance there is 1.25, or you could say 1 1/4 inches. Make sure, again, we're setting it up inches to miles and inches to miles. Next is our cross multiplication. We've seen this a lot. So 1 times x gets me 1x. And then over here, I've got to do 110. Sorry, guys. Looking for my calculator. I've got to get 110 times 1.25. So that comes out to give me 137.5. So that's it. We have 1x equals 137 miles. Okay, another word problem here where we have a scale model. That's a 3D model that is similar to a 3D object. So if we read problem 4, it says that a giant model heart is shown below. The heart is the ideal size for a person who is 170 feet tall. About what size would you expect the heart of a man who is 6 feet tall to be? So if I first take a look at this and come up with a little bit of a ratio, right now this heart, so if I set this up as heart to man, the actual human heart is what we're trying to find, and the man is 6 feet tall. The model that we see, that heart is 14 feet tall, and it said in the reading that the person would be 170 feet tall. So I want to put 170 there. So this is feet down here and feet up here, but it's heart to man, heart to man. And so from here, guys, we will begin our journey of cross multiplying. We get 170x equals 6 times 14, or 84. Divide by 170. Now, I know we're getting a decimal here, but it's okay. It said it's 0.49. This is 0.49, or we could say x is about 0.50 feet. I want you to think about that for a second. Half of a foot would technically be, so this is like saying x equals half of a foot, which equals 6 inches. That's pretty logical for your actual heart to be. Okay, so our assignment for today is the 2-8 practice that is in Canvas. It is going to be due on Monday. And I will go over these, so if you are struggling or have any trouble, we will discuss this on Monday. Email me if you guys have any questions. Hope you guys have a great day and a good weekend, and I'll see you guys Monday.